Hello everyone, I'm Daniel from Land Software, and in today's presentation I will do a small landscaping project using Land 4. And I'll show you how you can design and create different elements in relation with other existing objects. In this case, a constructed road on top of the terrain and the house, which is already hot linked in the project. But also how easy it is to adapt your new terrain in relation with these newly constructed objects, while having as a reference an existing terrain. In the last part of the presentation, we will compare the new terrain with the existing terrain using the volumetrics tool in Land 4. So I have first started by creating a couple of categories for each Land 4 objects I'm planning to build. And then for each category, I have created and assigned a layer. Now if I zoom in, we'll see the hot linked house, and I have placed a spot level in the pavement category at each corner of the house, but also around the stairs where it's slightly a different height. In the 3D, we can now see the hot linked house and also the spot levels placed in the corners. We can also place these spot levels in the 3D or in 2D. As you can see, the house is not yet adapted to the terrain, but we first build the pavement around and then adapt the new terrain to the pavement and the house. I'll first start by designing the pavement parameter, and I'll use a spline for that. So the spline just gives me more freedom into designing, but there I can just use a polyline or just a spline to create the ridge line or the contour line I would like to use. There are a couple of ways I could create my platform around the house. So using a couple of interpolation tools, I can establish the parameter and I can simply decide where I would like to have the fall and which interpolation tool suits me better. And I could, for instance, pick this one here and go with the gradient interpolation. This interpolation has a constant fall all around. So if I have a fall percentage of 2%, then I can place a spot level on the line. As you can see, this one has a dependency line because the child point, and it's in the pavement category. Now I know what's the height or what the height I want to have around the parameter, so I can just use this value and create a contour line out of my parameter. Using the create contour line function in ArchiCAD, I can simply transform this spline into a contour line having the same height all around. In this way, it's very easy to control your surface, and basically because the spot levels around the house at the corner of the house have the same height, I will have the same fall from the house to the edge. Now if I hide the existing terrain, because I start working with a new terrain now, I have the same spot levels, yet part of the new terrain. They are a copy from existing to new. And now I can start editing the new terrain and adapting to the construction. So I can just recreate it again. And now I can start deleting some of the spot levels which are within the area we are working in. I can already add this ridge line, which is part of the pavement category, to the new terrain. And in this way, we can see how it's adapting to the building. I can already start creating the pavement surface. And once I have the surface, I can also change the level lines height distance, or the threshold between the level lines, to maybe 5 centimeters. And once I have that, I can add composite to it. So I just need to select the composite I have created for the pavement. And if we go in the 3D view, we can already visualize the platform, which follows the ridge line and the spot levels at the corner of the house. Back to 2D, the level lines we have set in the 3D will also adapt in the 2D view. And also will be very easy to create a hole in the surface following the house parameter by simply using the fill tool. So here, if we go underneath, we can see now that our surface is strictly outside of the house area, but within the ridge line we established as the outer boundary of the pavement, and of course following the stairs and the spot levels we have inputted. I can of course place a fall line in between the spot levels representing the edge and the corner of the house, which will indicate the fall we have established through the interpolation. So I can now model the new terrain again. And once more, I want to add the ridge line, which defines the pavement parameter, and the ridge line, which defines the house parameter into the modeling. Now we have the new terrain adapted to the platform and to the road, of course. So now in the next step, I will build a ramp or road which will merge with the existing road. I will have to take into account the steepness of the terrain, so I will use a couple of tools to do that. So I'll start by designing the road geometry first, and I will use the spline tool for that. Could start somewhere in here. And of course, I need to take into account the length of the road and the steepness of the terrain. And I'll close it right at the existing road. Now having this will represent the middle of the road, so I can simply copy paste it and offset it for 2 meters. And then I can do the same on the other side. Once I'm happy with the design of my ramp, I can use the gravity tool, which reads value along the surface, and place spot levels at the junction with the road, but also at the junction with the paving. Once again, I can put a different color for these spot levels. In order to adapt the new terrain to the ramp, I will delete the spot level within the area. As you can see, the terrain adapts to it. In the next part, I will divide my ramp into a couple of segments, which I would like to use later into creating different raises along the ramp. In this way, it will be very easy to have control over the ridge lines I will create and to the surface representing the ramp. So now we have a couple of segments we're gonna work with. This will allow me to interpolate points or spot levels along a line with the falls or raise I want to use. I will start first with the first segment where I want to have not a very high raise from the platform towards the road. So I will use the value of this spot level where the platform starts or ends, and then I'll use create spot levels on a polyline or spline. So now I basically need to input the start point value, which is the height where the platform ends, and then I can input a raise. So I want my raise to be at 2%, and I want to have it as a ridge line, and I want custom distances. That means I can set the first spot level, and the last one will be generated according to that raise. In the 3D, we can now already visualize this. So we have now the first segment of the ramp with a 2% raise. I can continue with the next one, where again I will use the last spot level height to generate the line and the raise. And here I will use 12% raise. Again, I need to set the first and the last spot level. We can now see also the third segment representing the middle of the ramp. And for the last part, we can use the existing spot levels which were generated along. So I just use create ridgeline function and snap the spot levels to the line. Back to 3D, we now have finally all 4 segments representing the middle of the ramp. And it has different falls because there are basically 4 different ridge lines. Having that available now, I'm able to interpolate spot levels on both sides of the road. So I could use the gradient interpolation, where I can have a 2% fall on this side and then 1% fall on the other side. And then I can do the same for all. Now I can finally create the edges of the ramp using the spot levels I just generated and the spot levels where the ramp meets the road. I simply need to select the line and snap them one by one. Back to 3D, we can now finally see all 3 ridge lines, which will help me control and generate the ramp. So there are 4 segments which have a 2% fall on one side and 1% on the other one. Now I can finally create a surface. That's one side, and then I can also hide the new terrain. And then I create a surface for the second one. So I basically have 2 surfaces, which is very easy to be merged into one by using the fill consolidation tools. And now will be defined as one surface. I can now add the composite to it and change the arc segmentation, which will define how well defined it's going to be by the edges. And now we have the road already built. I can also set a different line threshold in between, which will help us visualize better the steepness of the road. I can of course place also fall lines in between the spot levels we have used to construct the ramp, which will indicate a fall in between the spot levels. I can create the new terrain again. Just this time I will use also the ridge lines representing the ramp, and of course the ridge line which defines the platform. And here is our new terrain, which already follows the road because we have used the ridge lines. And now that the ramp is done, we can also use the section tool to create a section across the ramp and visualize the result. the ramp together with the composites and the terrain. As an easy comparison, I can create the new terrain again without adding the ramp or the platform. And then if I generate it again, we can now see it in 3D. And this is basically very close to existing terrain yet. There were very few things modified except adding the ridgeline of the ramp and the ridgeline of the platform. Since I'm done creating the ramp and the platform, I can simply copy the ridgelines contained by these objects and categories into the Land for New category. Then all the future work would be easier without a need to make the selection of these ridgelines. As you can see, they are now highlighted automatically, and when creating the surface, they are already part of it. In the next part of the presentation, I will create the retaining walls going around the pavement. When constructing the retaining wall, I used a buffer line from the ridgeline showing the parameter of the pavement, and then using these lines I can generate a spot level at the exact height where the road meets the terrain. From here I can elevate it with 1 more meter, for instance, up to this point, and for here I can keep the same height up to this level. From here I can create a ridgeline and going back to the terrain. Now I'm having the ridgelines ready. So I have the first ridgeline, which represents the retaining wall outer boundary. And having that available, I'm now able to basically copy paste these lines and simply drag them back to the pavement. We now have 2 sets of lines, and this will define our retaining wall. Once I have my retaining wall ridgelines defined, I can now start creating the surfaces, so I will work in different areas. I will have basically 3 different surfaces, which they will stop at the precise height. I can now input the parameters of the retaining wall. I'll select surface with thickness and a thickness of 1 meter, add the surface material and the building material. We can now see it in the 3D. For the next surface, I'll use another parameter. So I will select terrain body, and I can input here a base level, which will be according to where the terrain meets the retaining wall. And again, adding the surface and the building material. Now being ready with the retaining wall, I can recreate the new terrain while adding the ridgelines of the new retaining wall to the surface. And this is our final result, where we can see that the new terrain meets the exact edge of the retaining wall using the common ridgelines. On the other side of the pavement, I'll use the same procedure, except that I'll elevate the spot levels and therefore the retaining wall with 20 centimeters above the pavement. Once that we are done designing and constructing the Land4 elements in our landscaping project, we can finally create the volumetrics where we can compare the new terrain to the existing terrain and obtain different parameters and information. In this view, we can see both terrains overlapped. And not the least, we have the resulting surface. Here we can map both the cut and the fill, as you can see now in the section. And not the least, we can place level lines on it. Back to plan view, we can also see the volumetric surface overlapped over our project. But not least, we have the volumetrics table where we have information about the horizontal projected area analytic surface, also which surfaces are compared, and information such as the fill and the cut, how much you have to add or remove from the site. This was Daniel from Land Software. Thank you for watching.